2,200 kilometers beneath your feet, something moved that should not have moved. In 2010, a massive current of molten iron buried deep inside Earth's outer core stopped flowing west and suddenly reversed, surging east instead. Scientists just confirmed it, using over 2 decades of satellite data. And here's the unsettling part. They still don't know why it happened. I'm Kinzo, and on this channel we dig into exactly this kind of story, the ones hiding in plain sight, buried in data. Nobody looked at closely enough until now. If that sounds like your kind of channel, stick around, because this one gets stranger the deeper we go. Let's start with what's actually down there. About 3,000 kilometers beneath the surface, past the crust, past the mantle, sits Earth's outer core. It's not solid. It's a swirling ocean of liquid iron and nickel, roughly the temperature of the sun's surface, constantly moving. That movement isn't random. It's the reason you have a working compass. It's the reason satellites don't get fried by solar radiation. It's the reason life on this planet is even possible. Think of it like a planet-sized dynamo, the same basic principle as the generator on a bicycle. Spinning liquid metal, conducting electricity, generating a magnetic field that wraps around the entire Earth. Scientists call this the geodynamo, and for decades, they believed they understood its basic behavior. Mostly westward flow. Slow, predictable, stable. Then a team led by Frederick Dahl Madsen at the University of Edinburgh's School of Geosciences went back through the numbers. Not just recent numbers either. They pulled data from 4 separate satellite missions, ESA's Swarm and CryoSat, Germany's CHAMP, and Denmark's Ørsted, stretching all the way back to 1997. 28 years of magnetic field measurements, compressed into one model, and buried inside that model was something nobody expected to find. Beneath the equatorial Pacific Ocean, in the year 2010, a massive region of that swirling liquid iron didn't just slow down, it flipped. A weak westward current suddenly became a strong eastward one. Not gradually, not predictably, just flipped. Here's why that single detail matters so much to people who study this for a living. You can't drill down 2,200 kilometers. Nobody has ever seen the outer core directly, and nobody ever will. Everything we know about it is inferred indirectly by watching how Earth's magnetic field behaves at the surface, then working backward to figure out what kind of movement down there could possibly cause it. It's a little like trying to figure out the exact shape of a hurricane by only watching how the leaves rustle in your backyard. For that method to work at all, scientists have always assumed the core moves in broadly consistent, large-scale patterns. Change slowly, stay stable across centuries, not years. This new analysis just broke that assumption. Madsen put it plainly. The large-scale flow reversal beneath the Pacific raises new questions about the behavior of Earth's deep interior. That's scientists speak for. We thought we understood the rules, and apparently we didn't. Now here's where this gets genuinely eerie. The team didn't just find one reversal. They found that the eastward surge, the one that began in 2010, has been quietly weakening again since 2020, which means whatever caused this isn't a permanent shift in how the planet works. It might be part of some kind of cycle, a pulse, something rhythmic happening deep inside Earth that we've simply never had the instruments to detect before now. Or it could be something else entirely. Nobody knows yet. That's not scientists being cagey. That's the honest, current state of the research. This isn't the first time Earth's deep interior has surprised the scientists studying it either. Back in 2023, a separate team of researchers, publishing in Nature Geoscience, made an equally strange claim. Earth's solid inner core, the ball of iron sitting at the very center of the planet, appeared to have slowed its rotation relative to the surface, possibly even reversed direction briefly, based on decades of seismic wave data from earthquakes passing straight through the planet's center. That finding was controversial. Other seismologists pushed back hard, arguing the data could be explained differently. The debate is still ongoing in academic circles today, but notice the pattern forming here. The inner core, potentially shifting its spin. The outer core, now confirmed reversing a major current beneath the Pacific. 2 separate research teams using 2 completely different methods, both finding evidence that the deepest parts of our planet behave far less predictably than textbooks have taught for generations. Neither team is claiming these 2 findings are directly connected. Scientific honesty means not overstating a link you can't yet prove. But it does mean geophysicists are increasingly treating Earth's interior as a far more dynamic, far less understood system than anyone assumed even 10 years ago. Let's talk about why this isn't just an abstract curiosity buried in an academic journal. Earth's magnetic field is the only thing standing between you and a direct hit from the solar wind, the constant stream of charged particles blasting off the sun at roughly 1,000,000 miles an hour. Without that field, the radiation would strip away our atmosphere. The same fate scientists believe happened to Mars billions of years ago. Every GPS signal, every satellite in orbit, every commercial flight route near the poles depends, in some way, on scientists correctly understanding how that magnetic field behaves and changes over time. Here's a real-world example you may have actually noticed without realizing why. Earth's magnetic North Pole isn't fixed, it drifts. For most of the 20th century, it moved slowly and predictably across the Canadian Arctic. Then, starting in the 1990s, it began accelerating, eventually racing towards Siberia at speeds that caught navigation experts off guard. The shift became so significant that in 2019, the World Magnetic Model, the exact system GPS devices, commercial airlines, and military navigation systems rely on, had to be updated early, outside its normal 5-year cycle, because the pole had moved too far, too fast, for the existing model to remain accurate. That single event should tell you something important. Changes happening thousands of kilometers beneath your feet don't stay buried down there. They ripple upward into the exact systems millions of people depend on every single day, often without ever knowing why. If the source of that field, the molten core itself, can suddenly reverse direction in a specific region without warning, that's not just a geology headline. That's a fundamental input into how we model space weather, satellite risk, and long-term changes, to the field that protects literally everyone on this planet. And there's another thread here that researchers are only just beginning to pull on. According to the study, this reversal might not be isolated to the outer core at all. Scientists are now exploring whether it connects to something happening at the core mantle boundary, the churning interface roughly 2,900 kilometers down, where the liquid outer core meets the solid rock of the mantle above it. If activity down there is somehow linked to what's happening in the outer core, that opens up an entirely new question. Is this specific reversal a local, isolated event, or is it a visible symptom of something bigger, happening deeper, that we haven't fully mapped yet? Right now, scientists genuinely don't know. And I want to be straight with you about that, because a lot of channels would take a mystery like this and turn it into a doomsday prediction. That's not what's happening here, and it's not what this channel does. This discovery does not mean Earth's magnetic field is about to collapse. It does not mean the poles are about to flip. Those are real geological phenomena, but nothing in this study suggests either one is imminent. It's worth explaining what a genuine pole flip actually is, since the term gets thrown around a lot online, usually incorrectly. A full geomagnetic reversal, where the north and south magnetic poles completely swap places, is a real documented phenomenon in Earth's geological history. It's happened hundreds of times over the planet's 4.5 billion year existence, preserved in the magnetic alignment of ancient volcanic rock. But here's the crucial detail most viral posts leave out. These reversals unfold over roughly 1,000 to 10,000 years, not overnight, not within a human lifetime, and certainly not as some sudden catastrophic event. The last full reversal happened around 780,000 years ago. This new study, about a regional current shifting direction beneath the Pacific, is a completely different scale of event. It's genuinely fascinating deep Earth science. It is not evidence of an imminent pole flip, and any video claiming otherwise is stretching the actual research well past what the scientists themselves are saying. What it does mean is something almost more interesting. For decades, textbooks described the core as slow-moving and steady. This data shows that in at least one region, it can shift direction within a matter of years, not centuries. That single fact is forcing geophysicists to rebuild parts of the model from the ground up. Let's sit with that for a second, because I think it's easy to breeze past just how strange this actually is. We've mapped the surface of Mars in more detail than we've mapped the inside of our own planet. We've sent spacecraft past Pluto. And there is a churning ocean of molten metal, twice the size of the moon, sitting directly beneath every single person watching this video right now, doing something we still can't fully explain. That's not science fiction. That's a peer-reviewed study published this year in the Journal of Studies of Earth's Deep Interior, built from real satellite data by real geophysicists at one of the oldest Earth sciences departments in the world. So what happens next? Madsen's team says the plan now is to keep watching. If this eastward surge continues weakening the way the data suggests, does it eventually flip back westward? Does it stabilize somewhere in between? Or does this become the new normal for that region of the core? Every future satellite pass, every new magnetic field measurement, adds another data point to a story that started with a strange blip in 2010 and is only now, 16 years later, being fully understood. That's genuinely the coolest part of this story to me. This wasn't detected in real time. Nobody knew it was happening while it was happening. It took over 2 decades of patient, unglamorous data collection and a team willing to go back and actually look closely to even find it in the first place. That's what real science looks like most of the time. Not a dramatic breaking news alert. A quiet, careful re-examination of data everyone already had that ends up revealing something nobody expected. If you're the kind of person who finds that genuinely fascinating rather than just scary, you're exactly who this channel is built for. I'm Kinzo, and every week on Kinzo Explain, We take stories like this one, real discoveries, real data, real scientists, and break them down without the hype and without the doom scrolling anxiety half the internet runs on. If you want to actually understand what's happening on this planet, and sometimes what's happening 2,000 kilometers beneath it, hit subscribe. It's free, it takes 2 seconds, and it directly determines whether stories like this reach more people who genuinely want to see them. Drop a comment and tell me this. If scientists confirmed one mystery process happening inside Earth's core, what do you think they haven't found yet? I read every single comment, and some of the best video ideas on this channel have come directly from what you all bring up down there. Because here's the truth this story leaves us with. We understand more about distant galaxies in some ways than we understand about the ground beneath our own feet. And every so often, a piece of overlooked data reminds us just how much of this planet is still, genuinely, a mystery. See you in the next one.